Electrosphere, the very own podcast of the EXAS department, proudly presented to you by the EXA committee. I'm Haider Rampurawala, your host for the second episode of Electrosphere. And today we have Dr. Ameya Nyayadhish as our guest. Welcome, sir.
Thank you.
So, introducing sir, he has done his B.Sc in physics from Shivaji University, his M.Sc in physics from University of Mumbai, and his PhD in high frequency electronics in 2022 from SRM University of Institute of Science and Technology. His research interests lie in nanofabrication, photolithography, work in a clean room environment in NTU, Singapore, and his publications include in the Nature Electronics. What is it? Nature Electronics.
Nature Electronics, it's a journal which has got a very high impact factor, around 32.
Okay. He has a publication in Nature Electronics journal having an impact factor of 30. So to start, we'd love to hear about your journey from being a student to a teacher. What made you pursue teaching as a career after working as a senior lecturer?
So I think I've started teaching at a very early stage of my life as a way to earn some bread and butter. So I was teaching when I was studying, and in a way, there's a feedback-driven mechanism. So I used to get a good feedback that what you're teaching is we are able to understand. So I thought I had a good communication ability, and at the same time I was very passionate about physics. So it was very happy experience for me to transfer that passion into the student. And probably that is the reason why I was pulled into the teaching profession, and I'm very happy to say that in last now almost 18 years now I'm in this profession.
That's wonderful to hear, sir. So now nanotechnology is a field that truly captivates the imagination. For our first year and second year students who are fascinated by this area and dream of building a career in it, what roadmap would you suggest they follow?
See, what happens typically for any branch engineer, they land up in getting a job in an IT company.
Right.
But you will see that past couple of years, the trend is shifting. With India getting into Make in India campaign, and the sector which has been targeted is the semiconductor manufacturing sector. Lots and lots of plants have already started functioning across the length and breadth of country. So there are at least 7 chip manufacturing plants which will be functioning by the end of next year in India. That is first motivation to get into core companies. Secondly, getting graduation in branches like electronics and computer science and spending an entire life in IT field is slightly uncalled for.
Right.
What you learn and what you do has a very little connection. Right. So it is always better to get into a field where you have an expertise into it. Right. As far as the scope in the field of nanotechnology is concerned, you'll see that a very recent event is this year's Nobel Prize in Physics.
Okay.
It is just announced a couple of days back, and it has gone for AI.
Okay.
Artificial intelligence, and almost half of the world is in a state of a confusion that how come the artificial intelligence fellow, AI fellow, has got a Nobel Prize in Physics.
Okay. Right.
Now there is a deep relation between AI and physics. There is something called the Boltzmann's machine. It's a very old concept. I'll give you an idea. That suppose you have a cousin, and somehow I met him, and I could recall or I could correlate, human brain can correlate that he looks like somebody that I know. And a little later on, over a little bit of a thinking, I come to know he's your cousin.
Okay.
So what my brain has done is it's compared the characteristics of a person with somebody which is already stored in my brain. The voice, the face, the body structure, and after comparing it with, I came up with the result, and I asked a fellow that, are you a cousin or a brother of so and so fellow, and he said yes.
Okay.
So precisely that is what AI is doing, and that is precisely what Boltzmann's machine is all about.
Okay.
So these two pair of scientists who have got Nobel Prize in 2024 in physics has done the same thing on a larger scale. So that is called data automation.
Okay.
So what does the data do is that it recognizes the pattern in the upcoming data stream with the data which is there, and even if the data is not known, it compares and generates an image out of it.
Right.
So all this requires a gigantic processing power.
Okay.
And without the nano devices. It is, I mean, even I would say rather than making it a nano device, we can call it a quantum computer. Without a quantum computer, the analysis of such finite data machines is impossible. So it's a huge scope as far as the nano and quantum computing fields are concerned.
So they probably needed these quantum computers to make this entire model?
Absolutely. I'll tell you what. In 60s, if somebody would have told that we are going to have a computer at home, it would have been taken as a joke. Right? Today, if I tell you that probably 20 years, 30 years down the line, a supercomputer will become a household device, will be taken as a joke.
Yes.
Nowadays, only big corporations are using supercomputers. But slowly, what's going to happen is, even our houses are going to become decision-making tools.
Correct.
Right now, we use IoT to an extent that suppose I have a running tab at my home and I'm in office, and my IoT device points it out that you have running tab.
Yes.
It doesn't switch it off. I have to manually switch it off.
Right. Yeah.
Right.
Yes.
And smart home will switch it off. It will not even bother to ask you.
Yes.
Isn't it? It will dim the lights automatically if nobody is there in the home. Right now, what do we have to do is IoT gives an interrupt.
Yes.
And you have to react to the interrupt on your cell phone.
Yes.
It just enables that global communication with the device and the person. But it doesn't take a decision on its own. So you need a smart machine for that.
Yes.
And another excellent example for this is why the pilots' salaries are going down.
Okay.
10 years down the line, 20 years down the line, pilots' profession was at peak. And now you'll see that they don't earn that much.
Okay.
Because planes are getting smarter and smarter.
Yes.
One of my friend is a pilot with an Air India which takes a flight from Mumbai to New York non-stop, 16 hours flight.
Okay.
And I asked him, how much time you fly? Within that 16 hours of a journey, how much time as a human you fly? So you will be very surprised to listen to the answer. 30 seconds.
Okay.
30 seconds is the control in the pilot's hand.
Okay.
Rest everything has been taken by a supercomputer on board. 15 seconds during takeoff and 15 seconds during landing. That is it.
Okay.
So now if one has to work for 30 seconds, I mean salary will also be proportional to that only, isn't it?
Okay.
So the profession has taken a hit because planes are getting smarter and smarter. Plane takes a lot of decisions on its own without even bothering the pilot. And that is because there is a hardware available on a computer. There is a supercomputer on board.
Okay.
You will see submarines are also these days are nuclear powered submarines.
Yes.
Now to handle a nuclear power is a raw power. Understand this. To modulate it and make it usable, you need a very intelligent system behind it.
Okay.
So since there is a supercomputer, it is able to do that. And one day or the other, our smartness, our need for smartness is going to increase. So there will be a supercomputer in every house. We have an electric meter in every house nowadays, isn't it? Likewise, a computer becomes an essential part, and slowly the computing power demand is going to increase. So it is, as far as the job opportunities are concerned, since it's going to become a household device, there are tons and tons of job opportunities into it.
Absolutely. That's wonderful. Okay. So let's dive in a little deeper in that. We know engineering physics can be quite challenging. How do you approach teaching these complex concepts and making them engaging and comprehensible for the students?
Now, our problem in the sense, our mindset is that what do we do is, we go by subject title.
Yes.
And we make a compartment in our head that I'm learning Maths 1, I'm learning engineering physics, I'm learning engineering chemistry. But you'll see, if we go slightly deeper into it, it's actually under a single umbrella of technology.
Yes.
These subject names are actually to cater the examination part.
Absolutely.
Isn't it? It is not to cater your understanding part.
Yes.
So when I approach a subject, I never approach it as engineering physics subject, but I approach it as some aspect of a technology. So it is really not specific to physics, and you will see that these boundaries are very faint now. We are talking about lithography, we are talking about nanofabrication, we are talking about high frequency electronics, none of which actually comes under conventional physics.
Okay.
Isn't it? All of these are actually comes under conventional electronics engineering.
Yes.
But somehow it has originated in physics.
Yes.
It has reached to a fabrication level where a device can be mass manufactured, and that is what we call it a technology today. Isn't it something that can be scaled up to mass manufacturing? Something that happens in the lab, we call it research, and we tag it with physics, chemistry, mathematics. But something that can be manufactured in a factory, we tag it with the technology. So now the boundary has become very thin, and the time span has also become very thin. See, what was a research used to get converted into technology, that time span was around 100 years. Like Einstein predicted the existence of lasers in 1916, 1917, and first laser came out in 1966. So it took around 50 odd years for the research to get converted into technology. But 6 nanometer device was in research 2 years down the line, and we have our cell phones now with a 6 nanometer technology. Within 2 years, the research has converted itself into a technology, isn't it? So that gap has bridged. So rather than going by a subject name, let's go by a broader umbrella of a technology. So it's very easy to correlate, and what I have understood is that if I am able to correlate, students are able to generate some interest into it. अरे हाँ ये मुझे समझ में आ रहा है because I'm using this device, and that is the bottom line here, is rather than going by compartments, let's go by a bigger picture.
Okay, that's great. Thank you, sir. Okay. It's clear you're deeply invested in fostering the next generation of researchers. What essential skills or qualities do you look in foreign students who express interest in working on research projects, and what advice would you give to them?
Okay. So it is a patience game. So when we were trying to make a diode, all right. Now diode is such a small device, and it's commercially available. But we were making a diode that can have a rectification ability at around 156 gigahertz.
Okay.
So we must have fabricated more than 30,000 diodes, none of which worked. Then we fabricated another 20-30,000 diodes. Couple of worked only for once or twice, and they burnt off.
Okay.
So here you have to have a belief and a patience. That is one thing. And there is a very age-old formula that sincerity plus hard work is going to give us a result. So you have to be convinced that what you do is what you like. You know, there is an interview by Apple founder Steve Jobs. It's in the YouTube public domain interview, that you have to love what you do. Otherwise, how you want to put up with it? Because it's going to get complicated, isn't it? I can put up with my kids, I can put up with my wife, I can put up with my students, because in a way I'm in love with them. But will I be able to do that with somebody who is a stranger? I may not be able to. So if you want to sustain in any field, you just have to find what you love and keep finding it. You test it to its merit, reject it on its merit, and something which you find that yes, I'll be able to, that is the mantra here, that find out a domain which you really into it. It can be anything, absolutely anything.
So if you were to take a student under your umbrella to help with research and everything, you would look for that, his or her love for physics. I would see whether the student is committed or not.
Right. Isn't it? If the student is committed to the subject, and a person can change. Today he is working under me, then he will move ahead. We had a student called Sahil Potnis. Okay. He was a biomedical student. Now he's settled in US, doing very well in his profession, and he was very committed to some work in electrical domain. Okay. So he contacted me. Since it was not my domain, I redirected him to Dr. Gajanan Nagare. Again, it was not his domain, so he directed him to somebody in IIT Madras. There he clicked. He did a 6 months project. That fellow recommended him in some big university in US, and now that. So people kept changing, but the interest was there, isn't it? So you have to devote yourself to your interest.
Okay. So now, broadening our scope a little bit, what would you say is the next big thing in physics or engineering innovations? Is there an area that you believe will have a transformative impact in the coming years, similar to what we've seen with AI?
That is the domain, actually. Artificial intelligence and integration of artificial intelligence in a biological systems. And you will see that what do we do today is, if suppose I have a headache, so I'm going to take a tablet which is actually sufficient for my entire body. Right? But my pain is localized.
Yes.
But the drug is global.
Yes.
It is reaching to every part of my body where it is actually not required.
Yes.
There is something called as a nano drug delivery system. So that is something which is again a medical application of artificial intelligence, which I feel is the next big thing, because the drug will be stored inside the body, released as per the need of the body by a computer which is placed inside the body. So suppose I am sleeping and I develop a symptom of some kind of a cardiac arrest. Now, I will come to know only if I get into the arrest.
Yes.
But the system, since it is monitoring my body 24/7, will alert almost everybody. Not only the alert, it will actually release the drug, which is stored inside my body. And people are working onto it. Now, next Nobel in medicine, just wait for a couple of days, is coming in this domain.
That's great. Awesome. So platforms like Smart India Hackathon and TIH provide such fantastic opportunities for students to apply their knowledge. How important do you think these experiences are on a student's resume, and would you encourage students to participate?
Definitely. See, if you talk about students in Vidyalankar, we come with one competitive exam, MHT CET, and students come here. If you try and analyze why these students are unable to get into IIT, is it that they're not talented? No. Is it that they have not worked hard? I don't think. They must have worked hard. I feel exposure to the national exam was not there when they were in schools, and so they were not ready for such national level competition, and so they couldn't perform. If you get into a national level competitions in 8th standard, 9th standard, 10th standard, probably the kid is more tuned that what exactly that we have to do for cracking these type of exams. When you go for competitions like SIH, when you go for competitions like TIH, you will understand that how others are doing, where the world is going, and you will be able to employ your faculties to the peak of their performance. Since you are into that competition zone, you will naturally perform well to win, and that becomes a habit. See, ultimately, motivation doesn't last long, isn't it? What lasts long, or what a person is made up of, is what kind of habits a person is going to carry. So if you have a habit of working under pressure, if you have a habit of performing to its peak, that you're going to do it everywhere. So competitions like this is actually giving you a skill set rather than a knowledge set. It's a skill set that you are acquiring, which will be useful in almost every situations. You take an example of a pilot training. Pilots were trained to take decisions in a split second. And this is something which is pilot training for the engineers. You will be trained to take decisions in a probably a split second time frame, so as to reduce the resources and maximize the benefits. So it's a training, and absolutely, as much as possible, students should participate. Look for more international level competitions, and must participate. And it's a thrilling experience.
Absolutely, sir. That was lovely, sir. Thank you for sharing that with us. It's been such a pleasure having you on Electrosphere.
Thank you so much. Thank you for calling me on this show. Thank you.
Okay. So, and to our listeners, thank you for tuning in. We hope you enjoyed this episode of Electrosphere. If you did, please leave us a review on Instagram and share it with your friends. Until next time, stay curious.
Thank you so much, guys.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you.